Good morning, everyone. This is Soumyaranjan Nahak. Welcome to my channel Renu Ratna Patsala. So I am here with new topic NFA of subject TOC. So today we are going to study about NFA. So we had already discussed about the DFA because NFA and DFA both are belongs to the finite automata and it belongs to the category of without output finite automata. So in today's class we will learn what is the property of NFA, what kind of tuple it carries, and what kind of example you will face on the basis of NFA in your exam. So first property will be NFA stands for non-deterministic finite automata. It stands for non-deterministic finite automata. Secondly, it contains so many paths for one input. Means path specification is totally different from DFA because it have so many paths for one input, but in case of DFA it have only one path for one input. So that is the difference between DFA and NFA. I will take another video, another class, and I will give you another video difference between NFA and DFA, and I will clarify about the DFA dead state configuration and dead configuration. Sorry, dead state and dead configuration. So it stands for non-deterministic finite automata. It contains so many paths for one input, and one more important thing is every NFA can be a DFA, can be DFA, but every DFA cannot be NFA. These are the characteristics, or we can call it property of NFA. NFA support null state, null value. It accept null value, but in case of DFA, you will never get a option of null value acceptance. So it stands for non-deterministic finite automata. It contains so many paths for one input, and every NFA can be a DFA, but every DFA cannot be NFA because there is difference between path specification. In case of DFA, you will get one path for one input, but in case of NFA, you will get so many paths for one input. So these are the property of NFA. One more property is it accept null value. There are so many properties. So write down. I will erase. Let me erase. It's like DFA. It have some tuples. In DFA, we are getting 5 types of tuples, but in case of NFA, we are getting 5 types of tuple like capital Q, sigma, Q0, F, delta. Capital Q, set of finite state. Sigma, number of input symbol, initial state, number of final state. This is a delta represent transition function. These are the property of NFA. Capital Q represent finite set, number of finite set, how many sets are available inside the machine. Sigma represent alphabet or number of input symbol. Q0 initial state. F, capital F represent final number of final state, and delta represent transition function. In case of DFA, you will get different kind of transition function. You will case of NFA. In case of NFA, you will get different kind of transition function. So write down or take screenshot. After that, I am going to explain about the examples of NFA. One more thing I am going to explain. In case of NFA, the transition function is delta Q represent 2 to the power Q. That is the transition function of NFA. But in case of DFA, you will get transition function is like this is the transition function of NFA. This is the transition function of DFA. This is the transition function of NFA. So write down, let me read it. I am going to do an example. Construct an NFA over sigma which contain two symbol, that is A and B, which will accept strings, double ones, where double ones followed by zeros. So according to the questions, first condition will be double one followed by single zero or zero. So that is the minimum strings in case of NFA. So we will try to construct a NFA machine. So initial state will be Q0. So minimum string, first we will write the minimum string 110 110 110 110 110 110. These are the examples of given questions. These are the string which is originated on the basis of given question, and the question is available here. Construct an NFA over an alphabet A, B, which will accept all string, where double ones followed by single zeros. So here we will try to accept the minimum string, that is 110. So we will put 1 here. We will create another state. We will create another 1 here, and for this one we will create another state here. So another symbol will be 0. This will be the final state. And we all know about the property of NFA as well as DFA. In case of NFA or DFA machine, you should have to create a machine which have a capacity to accept all the string which has originated on the basis of question. So these are the questions, these are the strings. It's like the question, or on the basis of the question we can create multiple strings. So minimum string will be 110 according to the question. So 110, and 0 is the final symbol which is executed at final state. Final state is marked by double circle. So next one will be 110 110. How it can possible when we are going to create a NFA machine? Let's have a look how to create a machine which can accept all the strings on the basis of question. So if we will put 0 or 1 here as a symbol in this transition, so it can accept all the strings according to the questions. So first minimum string will be 110, which is already accepted by the machine. Second string will be 110 110. So 1 1 0. Another one will come from looping transition, and another one will come from looping transition, because if we use a transition as a loop, that means we can use the value multiple time as per our requirement. So these are the question. This is the example of NFA. So we had already done all the we had already done or create all the strings according to the question. Whenever you are going to whenever you are facing a questions like it, first of all you have to focus upon the condition of a question. Then after you will create the minimum string under a language, that may be L or L1 or N, L2, and you will implement all the string upon a machine. And always try to construct a machine which can accept all the string according to the questions. So thank you. Have a great day. We will meet in next class with rest of the part.